All right, so hi gang, this is Mr. Flickner, and I thought I'd make a little video here to give you guys a hand with what we've been doing in class in case you've been absent or ill or trying to get caught up with what we're doing. So I'm going to break these segments down into two different categories. The first category I'm going to talk about is basically the side of a square, and then the second video I'm going to make has to do with estimating irrational side lengths. So let's get started right here. So a few days ago, like last Tuesday, we started working on a lab that was trying to help us understand how does the side of a square relate to its area. So we drew all of these squares that you see on this document right in here. And it started off really easy with these regular upright squares. They were easy to draw. And then we started working into these tilted squares over to here that some kids were able to come up with and then share their thinking about that as well. So the first part was about drawing squares, and then we took a few moments to talk about, well, how does the side of a square relate to its area? Well, it worked out okay with these guys in here. So we were able to look at this square here, and we can say, well, this square has an area of 1, and the side of it was 1. And this square over here has an area of 4. There are 4 squares in there, and so the side of that square was 2. And then this square in here, if you were to draw these lines in here, you would see that there are 9 squares in here, and the side of it is 3. And then this square over here, if you were to count in all the boxes in here, there's 1, 2, 3, 4, 4 times 4 is 16. You'd see that there are 16 squares in there. So we were able to sort of extrapolate that the side of a square essentially is what's called the root of its area, the square root or the dimension of its area. So we were able to draw that. We could come in and draw like this crazy. We were able to learn that this button right here means it's the root of its area. And this example here, the square root is 16. So we could say, well, the side of the square is the root of 16, which is 4. And that's sort of where we got started on that. And then we sort of came into these tilted squares in here, which were a lot of fun to draw, first of all. But the area was far more challenging to be able to figure out how big the area of that square was. And then at some point, there were some kids that were able to say, well, I recognize that if I connected the two vertices, like this guy here and this guy here, with this rectangle in here, then I can see that this whole rectangle is 2, and this part right here is half of 2. So this space that's in here has to be 1. So this space that's right in, right in, so I can draw this right in here. This space right in here has to be 1. That's one way that we were able to establish at least a part of that area in here. So like this square here is, so since the whole rectangle is 2 and half of this is 1, and then we were able to connect all of the vertices together and see that this part was 1, and then, oops. All right, come on now. Curses. So we could see that this guy right here, and then we could connect these two guys right here, and then we can connect these two guys right here, and then we can connect these two guys right in here. So we could draw these full rectangles, and we can see that this whole rectangle is 1, 2, and this is half of 2, so that makes that be 1, 1, 1, 1, 1. So this square that we were able to draw, we were able to establish that this square has an area of 5, which is kind of fun to be able to think about, because we were not able to be able to, well, anyway, we were able to come up with the fact that it has an area of 5. And then we were able to do the same thing over here. We were able, if we did the same sort of, connecting of squares, we were able to establish that this square has an area of I think it's 10, I think. Yeah, I think it's 10. So right in here, and then right in here, and this is where, and then right in here. So we could see that this rectangle that we can draw connecting these vertices is 1, 2, 3, and then half of 3 is 1.5. So 1.5, 1.5, 1.5, 1.5 plus 4 in the middle. So this is 1.5 and 1.5 makes 3, and then this over here makes 3, which makes 6, and then 4 makes 10. So this square altogether has an area of 10. This square has an area of 5. So that was the first part of the lesson, was to be able to say, well, can we draw squares, and then can we find the side length? Well, the side length was really easy to find when we had these upright squares in here, because it's just simply the root of its area. So if this is 16, then the root of 16 is 4. Or if it's 9, then we can say the root of 9 is 3, because 3 times 3 is 9. And over here we can say 4 times 4 is 16, or 1 times 1 is 1. Where it got challenging was with these tilted squares in here, because even though we can establish what the area is, like for example, we were able to prove a second ago that the area was 5, nothing times itself is 5. So we could, we could sort of estimate how big it is. Like if we were to say how long this line is, we can say, well, this line is like, it must be like 2.25 or 2.5 or something like that. So we were able to estimate, we can say, well, it must be about 2.5 or something like that. So the first part of the lesson was being able for us to be able to recognize, number one, that the side of a square is the root of its area. And what we learned is that, through a series of experimentation and etc., we were able to establish that, well, you can't really express this side length as a decimal like you can like this guy up here at the top. This guy over here of square root of 9, the side of it is called a perfect square. Excuse me, the area is called a perfect square because the side is a perfect number of 3.0. And this square over here of 4 is called a perfect square because the side of it has a side that's exactly 2. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Well, nothing times itself is 5. The best we can come up with is like an estimate. So if we were to use a calculator, we could sort of figure out that it's about 2.1 or 2.2 if we use a calculator, but this is a new type of number that we haven't seen before in the past, which is called an irrational number because nothing times itself is exactly 5. So the heart of the lesson was for us to know that, number one, you can find the area of a square and then you can express the side of a square as the root of its area. So in this example right here with 16, we could say the side of the square can be expressed in 2 different ways. When method number 1 is we can say it is exactly root 16, or we could say the side of the square is 4. And this guy over here, we could say the side of the square was root 5, or we could estimate it with some kind of a decimal approximation, like about 2.1 or 2.2 or something like that. And that was the heart of our first lesson.